Assalamu alaikum. My name is Muhammad Wayazulfkar and my registration ID is 16T37. In today's lecture, we are going to discuss about the decomposition. What is the decomposition? What are its types? And what are the advantages of these types? So, for begin the lecture, we will know looking towards first of all this what is the synthesis. The process of synthesis is the combining the signal through shifting, scaling, reversal properties and form new signal. This process is called synthesis. And what is the decomposition? Decomposition is the inverse process of synthesis in which we recover our signal through the various types, for example impulse types, for example through the impulse type, through the step type, through the even or odd signals, through the interlaced signals and Fourier transform. We are going to discuss these types one by one. So here are the following types of the decomposition. First of all is the impulse decomposition, and then next is the step, and next one is the even odd decomposition, and the next one is the interlaced decomposition, and the next one is the Fourier decomposition. This is impulse, step, even odd, interlaced, Fourier decomposition. So we are going to start this impulse decomposition. So let's first of all starting the impulse decomposition. First of all, we're looking towards the what is the impulse signal, how impulse signal behaves, what is the behavior of the impulse signal. So impulse signal defined as gives us the value of 1 at n is equal to 0 and 0 otherwise. That is, we get the value 1 only at n is equal to 0 and 0 otherwise. This gives us the value 1. For example, we have the signal as this is our signal. This is 1, this is 2, this is 3, for example 4 and 5 and 6. These are the highlights on the signal samples. So first of all, the first sample will, because it gives us the one value on n is equal to 0 and gives us the 0 otherwise. So first of all, we will take first sample of this signal. So that is, we will take only this first sample and will keep all these samples 0. And on the next sample, we will take the next sample and remain all these samples 0. This is 0. All these samples are zeros. On the next, we will take the next sample. This is the next sample and main all other these samples 0, and till on so on we will get the impulse decomposition. So one by one we sample each signal and this gives us the impulse decomposition. So coming to the advantages of this signal, it allows us to examine sample at a time. What we get through this process, we can check this one sample at a time. We can check the behavior of this sample at a time. For example, this is the only one sample, all other values on this sample is 0, so we can check the behavior of this sample. In the next second sample, we also check the behavior of this sample because it gives us only one sample and we can examine this sample easily. And the next thing, advantage of this system is system output can be calculated for any given output. System output is calculated for any given input. What does this mean? This means that if we have any input signal and we want to calculate the output, for example we have the complex signal and want to calculate our output, by doing this impulse decomposition, what we get our simple simplified. And next is simplified versions of signal. Simplified versions of signal. So these are the advantages of the impulse decomposition. The next decomposition which we are going to discuss is the step decomposition. For starting the step composition, we first look towards the what is the step signal. What is a step signal? Step signal is that signal which gives us the value of 1 for n greater than or equal to 0 and 0 for n less than 0. So this is our step signal. For example, let's look at the example of this signal. For example, we have the signal as which gives us the value of 0 at 1, and at 1 it gives 2, and at 2 it gives us minus 2. So we will decompose this signal as, firstly we will took all the values 1 at 0 and skip all other values, that is at 0 this is 1, at 1 this is 1 2 1 3 1 4 1 5 1 1 2 3 4 5 and so on till on the infinity. This will give us the value of 1. And in the next sample what we will find, because we have already calculated our 0 sample, so at 0 it will remain 0, at 1 it is 2 2 2 3 4 1 2 3 4, it will gives us the value of 2 until down to the infinity. And the next sample, what is this? This is start from the 2. What in this sample we get? We will get this sample as at 1 it is 0, it is 0, at 1 it is also 0, so it will start its value from 2, which is the minus 2 value, and then next value is minus 2 minus 2 minus 2, and it will till goes to up to infinity. This is minus 2, this is also minus 2, this is also minus 2 until up to infinity. This is 0, at 0 it is 0, at 1 it is also 0, because we already calculated this decomposition. So at 2 it is minus 2 3 4 5 6 and so on. So this is our step decomposition. Through step decomposition, what we get advantages of this is since this is the step composition, so it gives us the step values. Step values becomes easy for us, to calculate the values. So it is not the complex method to perform. So these are the advantages of the step decomposition. And next thing is even odd decomposition. What does we do in this composition? Even signal is that which has not, why when we put t minus t in place of t, then it has no effect on the signal. For example, cos of t signal, this is the example of the even signal. And what does we do in the odd signal? X of t is equal to minus x of t. What we get, we changes our signal. So by doing this composition, for example, we have the even signal as for cos, it is our even signal. We will divide this signal into different composition, and for the odd signal we have get this value as, this is our odd signal, this is our even signal. For example, we have this value and then this value. So this becomes the odd signal, because it starts from different positive side and ends on at the negative side. So this is our odd signal. Even and odd composition is used in Fourier transform analysis and Fourier series. So these are the main advantages of the even and odd composition. And the next composition, which is the interlaced composition. What is the interlaced composition? The interlaced decomposition. Sorry for that. Interlaced decomposition. What is the interlayer decomposition? First of all, we look what is the interlayer decomposition. This decomposition is used to improve the to improve the speed of our system by a factor of hundred and thousands, by a factor of hundred and thousands. So this is the interlayer decomposition. It is used to improve the speed of our system by a factor of hundred and thousands. The practical example and the theoretical example which we use in our system is that, for example, our system is very much slow. If we took this example in our the biology side, what we get the enzymes. This may be work as the interlayer decomposition. So this is for this lecture. We will meet in the next lecture. If you have any question or query, then leave in the comment section. Thank you very much.